Hello fellow Kickstarters, I'm Scott. I'm a mad computer scientist, and this is Project Light of War. For the better part of a year now, I've been developing a computer program capable of rendering 3D graphics using a method known as beam tracing. Initially, I was unsure that the idea was sound, let alone if it would yield greater benefit than its computational cost, but success in writing a proof of concept for the first stage has me convinced that my madness is closer to genius than insanity, if not by much. If you want to know how, there's plenty to read. I've placed documentation and source code on the project site, and I welcome discussion. But since you clicked this video, you probably want to know why, so here we go. When final quality is more important than time, graphic artists generating 3D scenery employ a technique called ray tracing to compute complex lighting effects by casting simulated rays of light from a camera point toward a virtual object. When a ray intersects the object, the intersection point is noted, and a second ray is cast toward each light source. The more light from each source, the greater the intensity of the corresponding pixel, and for every bounce of light, one or more rays are recast from the previous intersection, and the process is repeated. The result is vastly improved lighting, and effects like reflection and refraction are trivial to implement. However, ray tracing is not without its costs. In addition to added complexity, lines have no area, so each ray samples an infinitesimally small section of each surface, and what little it does sample is used to represent the entire pixel. This results in some of the same visual artifacts we encounter with traditional rendering methods, particularly aliasing, texture sampling, and interference patterns. If we replace the lines in ray tracing with a volume created by projecting the pixel into space, we can use linear algebra to solve the intersection between the volume and the object, and the result is another area. This area is then recast into a volume according to surface properties, and this becomes the next bounce. This is how ray tracing becomes beam tracing. Ray tracing is too slow to compute for most real-time purposes, and beam tracing, being moderately more complex, carries additional overhead, but it replaces separate anti-aliasing and texture filtering routines while retaining the same light propagation characteristics found in ray tracing. Furthermore, because each pixel is a series of beams, this method lends itself well to parallel processing, which, thanks to OpenCL, is nearly ubiquitous. Finally, I believe this design can be extended to support procedural surfaces. This will allow future artists to control how light behaves with each surface without generating static geometry or texture bitmaps. The goal of this project is to produce a free, open-source software framework for recursive beam tracing, with the intent to be included in any other project from plugins for existing software to high-quality offline rendering for independent games. Personally, I want to see improved post-processing for video game replays and machine cinema, among other things, and that's why I'm here. I want to put something really awesome into the hands and heads of the hacker, homebrew, and developer communities. Unfortunately, though, I'm at my financial limit, and I need help to finish. While I believe that the freedom to hack the final product is its own reward, Kickstarter suggests sweetening the deal with goodies. Who am I to question their logic? In return for your support, you can get a number of neat items, not only related to, but generated by this software. You can find more comprehensive lists to the right. Upon successful funding, I will gladly share incremental progress both on the project itself as well as steps toward fulfilling rewards. If this project is not funded, you get nothing, the project gets tabled, and I get to find a day job. And nobody wants that. So please, help me bring about an era of better artificial graphics by backing Project Light of War. Thank you.